technical problems during the webinar, we would recommend logging out and logging back in. So there will be a Q&A in the middle of the webinar and the final Q&A at the end, as we agreed. So please submit your questions and we will answer as many as we have time for.
Okay, so I would like to invite our first speakers. They will present on the types of study designs. They are Kavla Abu Hay, a fourth-year student from Al Ain University, UAE, and Nabil Ahmed, a fresh pharmacy graduate from Zawdin University, Pakistan. The panelists are Dr. Asim Ahmed Al-Noor, Assistant Professor at Al Ain University, and Dr. Bushra Hijazi, Assistant Professor at Jordan University. Hand over to you, Do.
Hello, everyone. It is an honor to be able to present on the IVPN platform before our esteemed guests. My name is Khala Wahed, a fourth-year pharmacy student and the vice leader of the Pharmacy Student Council at Al Ain University Abu Dhabi campus and member of the External Relations Committee at IVPN Student. Today, my colleague Nabil Ahmed and I will be presenting you our topic for today, types of research matching outcomes with design. So during this presentation, we aim to identify observational and experimental types of research design, and define each type of study design, outline the uses of each study type and their applications, as well as determine the limitation of each study type. So first off, I will be starting by introducing the terms research studies before moving on to explaining the various types of observational study designs, along with their uses and limitations. And then my colleague Nabil Ahmed will move on to continue in-depth explanation about the types of experimental studies. So first off, and in brief, research studies are in-depth or intensive investigations of specific subject or question involving observation, collection, as well as analysis of data for the purpose of increasing knowledge about a specific topic or answering questions. Now, types of research may be divided into two main types, observational and experimental, and I will be starting off with observational studies. So observational studies, researchers usually do not interfere with the actions or environment of the study participants and simply observe the effects of a certain risk factor, diagnostic test, or another intervention that the participants are already exposed to or would be exposed to regardless of participation in the study. Now, one such type of observational study is a cohort study, which oftentimes compares two groups, one exposed to a certain variable and referred to as the experimental group, and the other not exposed to the variable and referred to as the control group. Now, both groups are monitored over prolonged periods of times to check for the incidence of outcomes. Now, the study can either be retrospective or prospective. In retrospective studies, we observe records of certain individuals from the past in comparison with prospective, where the subjects are monitored in real time for those outcomes. Now, one such example of such study is the effect of smoking on cardiac function. Two groups may be chosen, one where subjects do smoke and the other where subjects do not smoke, and they are monitored for the incidence or prevalence of decreasing or increasing improved cardiac function. This is one such example. Now, of course, every type of study has its limitations, and in this case, limitations of the cohort study include changing of variables. Of course, the study is usually long, so due to the prolonged time, there are more valuable variables that are known to interfere with the results and might decrease the validity of the study. Now, there is also low external validity due to the lack of randomization, as in the subjects are chosen by the researchers rather by randomization, which my colleague will be expanding upon later. Now, also there are a chance that confounding variables might interfere with the study, and confounding variables may affect the outcomes. And there are variables that are variables differing from the ones that are being studied or observed by the study. Now, moving on, we have also case control studies, which are similar to cohort studies, but different in that they can only be retrospective, as they observe individuals that already have the outcomes specified and are monitored for risk factors and exposure versus a group that do not have that outcome but have similar characteristics and are monitored to check if they later develop the outcome and with risk factors or variables that led to that progression or development of the disease. Now, such example is in patients with breast cancer and are monitored for the progression of the disease versus another group which have similar characteristics and similar exposure in terms of environmental or on the terms of biological health. And they are monitored to check if they later develop the outcome and risk factors or variables led to that. Now, the limitations of such study include recall bias, where patients with those outcomes are more likely to identify risk factors that could have possibly contributed to the disease versus the other group, which have not yet and hopefully did not develop the outcome. Now, another problem is the lack of randomization, which is actually prevalent or is a limitation across all types of observational studies. And the final problem, or one of the problems, of course, there are many limitations to those studies. This limitation is that the study includes participants with a certain outcome and such limit the possibility of correlating such risk factors to other possible outcomes. Now, another type of study is the cross-sectional type of study, which examines a group of individuals at a certain point in time to observe certain characteristics without making any type of associations. So such an example is determining of the prevalence of a certain disease, for example, among a certain demographic at a certain point in time. Now, the limitations of this study include that the participants may not many participants would fit the criteria. So this would be a limitation to the study in terms of finding enough research participants. Also, the lack of ability to determine causation and effect, and the lack of historical context to explain the results collected, which explains the lack of causation and the effect in the study. Now, moving on to a similar type of study, we have the case series study, which is actually a study that provides in-depth detail about a specific group of people with a specific outcome. One such example is a group of individuals suffering from COVID-19 infection, and the study will provide detailed information about the progression of the disease as well as the treatments provided. Now, limitations may include, now usually the participants share very similar characteristics, almost identical in terms of the disease itself. And the limitations to such a study is that there is an inability to generalize because a small sample size is chosen with people who do fit certain criteria, and there is over interpretation of the results due to that small sample size. So the results may be exaggerated versus if there was a larger pool of participants. And there's also, similarly to the cross-section studies, there's no causation and effect in these types of studies. Now, my colleague Nabil Ahmed will continue on with experimental studies. Thank you.
Thank you so much, caller, for such a detailed uh, introduction to the topic and then the observational studies. And Assalamu alaikum, everyone. I'm Nabil. I'm a pharmacy graduate from Ziauddin University. I was the president of the Scientific Society at Ziauddin Scientific Club, and right now a member of Public Health Committee, IVPN. The topic which I'm going to introduce today is scientific studies, experimental scientific studies. What are basically the experimental studies? Let us know first how it differs from the observational studies. In the experimental studies, the qualitative method is not used, but a quantitative research method is allowed. The quantitative research method allows us to verify the change which is being observed in any drug or any surgical process that are basically taking place. in the experimental studies, we actually prove that there is a change going on, there is an intervention going on, and we do not that basically this is the change that has been introduced. What are the key points in the experimental studies? First of all, the experimental studies are the studies in which
Nabil, I'm so sorry to interrupt, but your voice keeps cutting in the middle. Can you please see what to do?
Okay.
I'm so sorry.
Is it all right now?
Yeah, now it's okay. It just gets cut in the middle, so.
Okay. What are the key points in the experimental studies? In the experimental studies, we actually study the interventions that are taking place in the study. In the experimental studies, there are at least two groups present, one of which is a control group and another one is uncontrolled. In the control group, we follow the differences which are taking place in the group of one in which we have administered the drug in which the effect is taking place, and the other group is set free or it should be given a placebo. We all know what a placebo is. Basically, it's a drug which doesn't have any effect on the human body. Now moving on to some key points which are important if you are studying the experimental studies. First of all, randomization. Randomization means we have to select each participant from a specific criteria in order to meet. If I want to conduct a study in the whole world, I should make sure that each and every member of the ethical race, of the gender, of the society is being included so that my result apply to all of the participants that were present in all of the world. Now comes to the blinding. The blinding of the study is basically the second most important term in the experimental studies. The blinding states that if the participant actually knows what kind of drug he is getting. There are two kinds of blinding studies present. First of all, it's a single blind in which only the participant is not known about the drug, but a doctor is being known. Secondly, there is a double blind clinical study in which both the participant and the doctors both are not known what the actually drug performs the function. Without any biasness, and we get to know that actually drug is making a difference. Thirdly, the controlled and uncontrolled groups. In the controlled groups, the patient do not get the investigational drug and but also get the drug which makes the effect. Then in the end we compares both of the groups with each other and make sure there is a difference among one of them, because obviously one of them is getting the drug and one of them is not. So in controlled and uncontrolled studies, we get the difference among the groups which we are studying by administering the drug in the one which is not present. Now, there is an example of the terms which I described previously. It is a study which was conducted on the DNA MVERP trap, in which a randomized double-blind control vaccine was given. Randomized means the participants were selected without any biasness. Double blind, both the participant and the doctor was not known about the drug. And thirdly, it was a controlled trial, means there was a actual difference between the one in which the drug was administered or the vaccine was administered or the one in which it was not. Now let's come to the type of the experimental studies. There are three basic types. First of all, there is pre-experimental studies. Secondly, it is true experimental studies, and third, it is quasi-experimental studies. Now let's come to the pre-experimental studies. The pre-experimental, like the word shows, these are the one which are done before performing a specific experiment to anything. Pre-experimental studies are the most simplest form, because in this study we are not concluding anything, we are not randomizing anything. It's just a study to make sure that there is some change going on in the society. For example, I want to know that by changing the exercise plan of my client, I can actually get him lose some weight. So it is an example of a pre-experimental studies in which I am being specific, I am not randomizing anything, and I am just making a change to see if it makes any difference. If I get successful in the pre-experimental studies, then I can continue with the another type, which is true experimental studies. The true experimental studies are the more accurate and reliable studies because in these studies, we are actually randomizing the groups. The distribution is very random and we are making a control variable. What is a control variable? We actually think of the effect which we are producing and then we make it constant. For example of true experimental studies, we considered that I want to know the cause and effect link of any drug. If I want to know the cause and effect link of any drug, I must include the participants which are actually going through that disease. I will consider the participants, I will administer them the drugs, I will then prove with the statistical analysis that the drug which I have given them is actually improving their health through the probability values which you will further study in the next sessions. So the true experimental studies are the best studies which are with maximum accuracy and they are worldwide done in order to establish a fact. Now let's come to the last of the study, which is QSI experimental research. Basically, it is highly specific to a provident end in which we actually make a difference while selecting the population we actually need. The example of QSI experimental studies will make you understand how it is differentiated from the others. For example, a memory test with a group of clinically depressed participants compared to the controlled group of non-depressed. At one hand, I have taken the group of participants which are clinically depressed, and another hand, I have taken non-depressed. In both of them, I have administered the drugs. So obviously, in the patients who are depressed, the drug will work more efficiently while compared to the non-depressed. The depressed should be as equals to the non-depressed so that I know that drug has been worked. The drug is working perfectly. So that's how in QSI discovered, which is already discovered, or we want to establish a routine work analysis more accurate, that actually we have made a drug which is this much effective and this much safe. So this is all from my end of about the experimental studies. These are the references provided of above literature. If you have any questions, you can ask. Thank you so much.
Okay, so thank you so much, Kavla and Nabil. You went great. Now I'd like to call Dr. Bushra and Dr. Asim to ask questions from our speakers. Dr. Bushra and Dr. Asim.
Yes, thank you so much for this opportunity. I want to ask what's her name? The Ikram?
Yes, Nabil and Kavla.
Khawla, can you explain to me what is the difference between incidence and prevalence?
I believe that incidence is more related to the past, while prevalence is more related to the present. So prevalence may be current, but incidence may be related to the past and a comparison with those who do not have it, in comparison with prevalence, which is more of the amount that have it. So incidence is more related to statistical analysis, perhaps, in comparison with the prevalence.
Nabil, do you have another answer for this question?
Just the same one. I just want to add the prevalence is the rate at which the disease is like spreading in a society. It is actually prevalence, and the incidence is if it is occurring by any chance to a specific population.
Actually, the incidence is number of new cases in certain point of time, while prevalence number of all cases. So when you talked about cohort study, you said it measure incidence and the prevalence. So it's not correct to mention that cohort study measure prevalence. Cohort study only measure incidence, while cross-sectional study, you also mentioned there it measure prevalence, which is correct. So cohort study measure incidence because we observe how many new cases or outcomes are coming up. So this is incidence. However, cross-sectional study, we are measuring whether the case is new, old, whatever, at certain point of time, we are measuring how prevalent is the outcome, the disease, etc. So this is the difference between incidence and prevalence. Nabil, can you go to your definition of randomization?
Randomization is basically a process in which,
Can you go back in the slides so we can
yeah,
see?
sure.
Yes. So I know what you said exactly, but I need also the audience to see the definition. Okay. Yes. So can you explain it again?
Basically, what randomization is that every member of the population must have an equal chance. For example, if the genders are being observed, then the male and female both should be included. If the races are being observed, then all the races should be included. If the other factors also.
So is there a difference between random sampling and randomization in randomized clinical trial?
No, I don't think there is any difference because both are done through the same process. I highlighted the term which is randomization through this important terminology, not the whole.
So randomization and random sampling, to be honest, they are different. So randomization in randomized control trial means that we are giving a random assignment to
Oh,
each
yes.
subject to be assigned to either intervention or control group. So the randomization is the random assignment, not the simple random sampling or in the that we are using in a sampling design. So sampling design could be simple random sampling, maybe stratified,
Certified clustered.
cluster, systematic, or
Yes.
non-probability convenience or consecutive sampling. However, the randomization in the randomized clinical trial means random assignment. We are
Assignments.
giving any subjects are met the inclusion or exclusion criteria after choosing the subject, which whether any sampling design we use, maybe we'll use convenience sampling. After that, we will do randomization. So randomization is the random assignment, is not the random selection of the subject from the population. So we have the sample with us, then we randomize them either to intervention group or control group. So we're giving them equal opportunity to be randomized. Also, what is the randomization benefit us? You already mentioned that.
Yes, the randomization benefits us in providing the result which can be implemented to all the population in the world. It should not be, it is not like we are only selecting a one specific group of people and we are testing the product on this. So randomization provides a result which can be worldwide used.
Yeah, so the benefit of randomization, it's to control the confounder. So you said in cohort study, Hawla, you said that we don't have, one of the limitation is the confounding variables. And the confounding variables are these variables that are not the interest of our research, however, they're affecting the outcome, right? So in randomization, we are making sure that we are randomizing the confounders to either intervention or to control groups. So we have almost identical group of subjects in the intervention or control group. So the confounders like gender, age, other factors that maybe smoking status, whatever, that maybe they will affect our outcome, but we are making sure that at baseline they are equally distributed between the intervention and control group. So this is the randomization process. So it will distribute the confounders and we make sure that each we don't have confounding bias. Okay, that's my question. Very great presentation. Thank you.
Thank you.
So, Dr. Asim, would you like to ask the questions?
Yeah, sure. Thank you very much. Thank you for organizers, IVPN team for this great opportunity. I would like to ask Ms. Hawla regarding the most important aspect of selecting a study design in order to conduct a trial. What do you think the most important factor that you would consider in order to select a study design, whether being a random study design, experimental, non-experimental, observational, etc.? What would be the most important factor that you would consider in order to select the study design? Thank you.
Thank you for your question, Dr. Asim. I believe that is related to what outcomes or what's the purpose of the topic of study. For example, if what you want to know is the determination of the effect of a new drug on certain population or certain patients, then what you need to do is clinical trials, for example. So it all bases upon what is the purpose or for what use you need that type of design. So it depends on your question or your hypothesis or so on.
Thank you.
Yes.
Great. The other question I would like to ask you, where do you place an interrupted time series with regard to experimental methods? Interrupted time series, the type of study design that has a certain criteria. Where would you like to place it in terms of experimental and non-experimental trials?
I think it will be, is the question to me?
Yep, if you please.
Thank you
Thank
for the
you.
question. I think we will place it in the statistical studies because it is more likely to be time related.
Okay. Would it be a randomized trial?
No, it will not be randomized.
Okay. Yeah. In timed interrupted time series, actually, it's just like the study design of pre and post. And in terms of statistics, you will use an ad hoc statistical analysis, most probably. Thank you very
Thank
much.
you.
Thank you. Well done presentation. Very
Thank you.
informative and very simple, very direct, and touches really the most important part. Thank you.
Thank you.
Thank you, Dr. Asim. Thank you all. Okay, so now I would like to introduce our next speakers, Ruth Alex and Fatma Bashir, fifth-year students from Gulf Medical University, UAE. They will teach us about different forms of data in research. The panelists are Dr. Grit Dijk and Dr. Bushra Hijazi. So hands over to you, Ruth and Fatma.
Hello, everyone. Okay. So me and Fatima Bashir, my colleague, we're representing Gulf Medical University. Firstly, we would like to thank Ahmed and the whole IVPN student team for giving us this opportunity. And our topic for today is data variables, exploring the basics. So we learned about type of studies, and we're really taking a step back to go to the very basics, which is when you collect your data for your research, you need to, before you do a statistical test, you need to actually divide them into the type of variables that are there. So just we want to talk about the type of variables and just tell you about the types, yeah. So for today, our learning objectives are to first differentiate between data and variable. Even though these are used very interchangeably, there is a difference between them. Understand the different types of data in research and apply this to real-life examples. We'll be talking about what data is, types of variable, the difference between qualitative and quantitative variables, difference between nominal and ordinal, the difference between continuous and discrete, and finally, independent versus independent. I will hand over to my colleague, Fatima Bashir.
Hello, everyone. My name is Fatima Bashir, and I'll start the first part, which is what data is. So usually we know that data are pieces of information about individuals organized into variables. And variables, to put it in a layman's term, it means that something that can change and can have more than one value. So it's the characteristics of a subject that varies from subject to subject. So as you can see from this table, everything is data, but variable is the one that sorts them out into each subject that it divides from. And I'm going to ask you a question, and you can answer it in the question box and chat it up with me because there's no place to write it down. So I'm going to ask which one of these are variable? Which one do you think is a variable? And we're going to see the replies. Okay, we already have a reply by Fatima. She said all of them are variables, which is correct. All of them are variables from height to income and blood pressure. They're all variables. So thank you so much, Fatima, for your reply. Next, we're going to discuss the type of variables. So variables have like this from this tree table. You can see there's a random variable, which is divided into two, the qualitative, which is the categorical, and the quantitative variable. So the qualitative has subdivisions, which is the nominal and ordinal, which are the common ones, and the quantitative, which is divided into continuous and discrete. So I'm going to give you like a little comic to understand more on what the difference between quantitative and qualitative is. So we're going to imagine this man is selling he's giving out free ice cream, and there's this other person behind the bush trying to understand, oh, there is only one inch can take the free ice cream. That's interesting. He's given us a particular number of the people that can take the free ice cream. So when he went to his friend to discuss what did he feel about the free ice cream, when he saw the free ice cream, his friend told him he's a little excited, he's a little scared. And why was that? This differentiates between quantity, which means numbers, and quality, which means the feelings, the emotions, the expressions that was given when they saw the free ice cream. So this is the difference between qualitative and quantitative. And which means qualitative variable describes the qualities and characteristics, and it's descriptive. It expresses terms in terms of feeling rather than numerical values, so there's no number added. So it cannot be counted or measured as well. So it rather describes just the data. It's just the name, like gender, for example, or educational level. We just describe the quality. We do not describe them in terms of numbers, or marital status as well. So the subtypes of qualitative variables, we have the nominal, we have binomial and ordinal, where I'll start with the nominal data. So nominal is classified into groups of unordered manner. They have no indication or relative severity. Let's say hair color. We cannot compare like black, yellow, or brown hair color. We cannot severe them into which one is greater or which one is worse. They are just naturally there and created there. Or nationality as well. You can't be, it's either like Egyptian or Indian, or you can be Nigerian, or rather marital status. They are all naturally there. It's either you're single, married, or divorced. They cannot be rated in terms of severity or can be ordered as well. Next, we have the binomial. So as we know, binary means two. So this binomial is like the data can only be in only one of the two categories. The answer is either yes or no. It's either 1 or 0 or off or on. Example, when you take COVID PCR, it's either positive or negative. It can't be in between. Or when mortality happens, it's either yes or no. Or if they ask chronic conditions, it's either you have chronic conditions or you don't. So this is the two types, binomial, two pieces, two categories rather. And the last one is the ordinal, where we rank in specific order, but with no consistent level of magnitude of difference between the ranks. Example is the GFR stages. We have like stage 1, 2, 3, 4, and 5, where they are ranked in like specific order, like stage 1 to 2, and then stage 5. They're all ranked with no level of magnitude or difference between the ranks. Or another example is the educational level, where we have like school and then university and then masters. So they are in order, they are ranked in terms of, okay, or economical status. We can see poor, middle, or rich. We know that poor means that there's low income, middle means the middle income, and then rich means there's more money compared to the poor. So there is ranking in this. And I'll be handing over to Ruth to continue this session.
Okay, as Fatima really well explained about qualitative variables, I hope you understood. So I'll be talking about the other type of variables, which is quantitative variables. So when you hear the word quantity, it's very obvious to me that it's numbers. So that's an easy way to understand in your research what is a quantitative variable. They will always have numbers. So they are a measure of value or counts, and it's shown as numbers. So the questions that are usually asked in your survey or questionnaire will be how many, how much, how often. So it's all numbers. For example, you have an exam score here, and you can see this person got 100%. So 100% is a number, so it's a quantitative variable. I would like to note that if it's in grades like A+, B, C, then it would actually be ordinal, which is qualitative. So that's something interesting. Your bank balance will be quantitative because it's in numbers, and number of people in your family, which is also a quantitative variable. So quantitative variables are of two types, discrete and continuous. Discrete variables they only take certain values. So when we studied math in school, one of the basic math lessons we learn is whole numbers. So whole numbers are 0, 1, 2, 3, 4, and so on. So the decimal points and fractions are not whole numbers. So in case of a discrete variable, your data will only have whole numbers. For example, is age. When you look at age, how old are you? You don't really say I'm 22 years and a half. When you are filling in a questionnaire, you only put your age. So that's an example of a discrete variable. Another example is number of cats. So there's never going to be 4.5 cats or 2.5 cats. It's always going to be a whole number. So that's a good way or indication of how you can understand what a discrete variable is. It has a finite number of values. The other type of quantitative variable is a continuous variable. So this variable can have decimal points or can have fractions. For example, height. When you look at height, you can be 5 foot and 2 inches. So that's 5.2. You can be, I'm 5.2 inches. That's why I said that. You can be 7.1. You can even be 7. So it's a continuous scale. So you can have an infinite number of possibilities. Or when you look in your practice, you look at patients' temperature, you'll never find patients always with 36 degrees Celsius, 37 degrees Celsius. They'll always be lying on that decimal scale. So that's how you know if a variable is a continuous variable. So I have an activity for you. I would like this to be a very interactive session. So I have two pictures here, picture A and picture B. I want you to tell me which of these is a discrete variable and which of these is a continuous variable. You can put it down in the chat box. I'll give you a few minutes. Okay, I have one answer. Would anybody else like to answer? Okay, perfect. A is continuous and B is discrete. So weight, you're never only 68 kg. You will always have that point unless your weighing machine is broken. So weight is a continuous variable. So if you ever do your research, you know that weight has to be continuous. And number of children, you're never going to have 10.5 children. So that's discrete. So we've gone through qualitative and quantitative. So this is just a table of examples just to see that gender is qualitative. Another word for qualitative is categorical. So if you ever see something that says categorical variable, I don't want you to get confused. It means qualitative. Social class, qualifications, type of instructions. On the other hand, quantitative, also called numerical, is age, height, weight, income, university size, so everything that does with numbers. So moving on from qualitative, quantitative one, so why is this important? So it's a little boring. You can say that it's so simple. So why is it important to change things into qualitative, quantitative, continuous? So it's all because of the test that you have to use. So once you collect all your data, you need to actually do statistical analysis. So to do analysis, you have different types of tests. So, and somebody else will discuss this, but I just wanted to know the importance of the different types of variables. And so knowing what kind of variable you have will help you choose your test. Okay. So one final thing that I want to discuss that is important is independent and dependent variables, and you will see this in research. It's very self-explanatory. So an independent variable is something that you change, that is fine on its own. It stays on its own and it influences other variables. While a dependent variable, it it changes because of the independent variable or because of the change you make. For my example here is I have two plants. In one plant, I put 1 bottle of water and the plant only grows this high. But on the other plant, I put 2 bottles of water, so the plant grows way high. So the thing that I'm changing here is the amount of water. So that is my independent variable. But, and the size of the plant depends on the amount of water. So that's my dependent variable. And so a simple way to say it is the independent variable is the cause or is what you change or manipulate. And the dependent variable is the effect that happens because of that change. So I just wanted to put this in perspective of our practice. So for example, a patient comes to you and you give the patient a low dose of medication. And imagine the patient has hypertension. So because you have a low dose, maybe 10 mg of your medication, there was no change in blood pressure. But when you increase that dose to 20 mg, you can see that the blood pressure is lowered. So my independent variable that I'm changing here is the dose of my drug. And another thing is I give him a placebo, and which causes no change in blood pressure. So what is changing here is blood pressure because of the drug that I'm giving. So I can apply different levels of the independent variable, and then I get to measure the effect on the dependent variable. Another example that we use commonly in randomized control trials is we have group A on an active medication and group B on a placebo. And then you see the response. So the independent variable that we are changing here is whether the medication is active or a placebo, and the participant response is the dependent variable. So these are the references we use during our presentation. Thank you for listening, and feel free to ask us any questions.
Okay, so thank you, Ruth and Fatma. It was amazing. And now I would like Dr. Grit and Dr. Bushra to ask questions from our speakers.
Shall I go first? Okay, that was an amazing presentation. I really enjoyed it. Thank you very much. That was very well presented and very clear. I would like, if you can explain and expand more, not just on qualitative variables, but how I would analyze and go about analyzing qualitative variables, please, because that's something that people have asked a lot about in the past.
So when you get qualitative variables, so first you have to see if it's categorical. And if it's categorical, you see if it's bivariate or multivariate. So the difference between bivariate or multivariate is if you have 2 different variables you want to look at or more than 2. So that will help you choose your test. So when you first get all your variables in your research, it's very important to code it, which is something that you don't know until you do a research. You'll have to put it in terms of zeros and ones, which makes the software analyze it. And then you get to choose your type of test. For example, if your variables are categorical and bivariate, you can use chi-square test or even 2-sample proportion test. But if it is categorical and continuous, then you can use 2-sample t-test if it's normal data. But if it is not normally distributed, you can use Mad-Whitney U-test. So I don't really know how to explain very well in detail because I didn't prepare for that, but that's just a very simple way of how I can explain.
That's a good answer. Thank you very much. I mean, it's very subjective, isn't it? Don't you think, the way that people would collect qualitative data? But in our field, in your field, it's very common for researchers to collect qualitative data. So thank you for your answer. I pass to my colleague.
Okay, thank you for this presentation. So you talked about the analysis, back to Dr. Garth's question. You talked about Mann-Whitney, etc., but you did not mention about this descriptive statistics. What are kind of descriptive statistics for the qualitative versus the quantitative?
Is descriptive statistics measures of central tendency?
One of them, yes.
Yeah, so
or either central tendency or dispersion.
Yeah, so depending on the data that you collect, you can do different type of tests, which will be explained by the next presenter. Like mean, it depends if your data is normally distributed, which is something important that you need to look, and that will help you choose between like mean, median, mode, and also
So which one mean is for which, and mode or median for which?
I think I can help from here. Like mean, median, and mode are the measures for central tendency.
Yes, yes. So what is the answer? So for quantitative, we measure the mean. Okay. We have like, because we have numbers and we can have their mean and we can rank and we can have perform all statistical analysis for them. While for qualitative, we measure proportion, frequency, median, this kind of thing. But for quantitative, we measure the mean, standard deviation, this kind of thing. That's why with your qualitative, you use go back to the slide that you got when Dr. Gareth. So that's why mostly you went to non-parametric test when you had a qualitative data, because you cannot perform a quantitative analysis mostly for, like, you went to categorical to sample Z proportion test because you measure proportion, not mean. So it's proportion, frequency, median, while for quantitative, you measure the mean, the average, which is the average also, and the standard deviation, etc., or variance. Okay.
Okay, thank you, doctors.
So yeah, and another question for continuous variable, you said there is discrete and continuous. Do you know the difference between ratio and interval? Did you happen to come up with the ratio and interval?
If I'm not wrong, ratio is in fractions or decimals.
What the temperature is example is what?
So I would say if you're looking of interval.
Yes. So it's talking about which one has a true zero or which one doesn't have a true zero. For example, temperature Celsius, we have a zero, but is it a true zero?
No, interval.
No.
Scales have no true zero.
Yeah.
Well, the ratio, like the interval scales represent values below zero. So
yes, we can have temperature below zero. Yes. That's my questions. Thank you so much.
Thank you, doctor.
Thank you, Dr. Gareth and Dr. Bushra. Handing over to my colleague, Maria.
Now we'll be moving on to the next part of the session with Shaima Abu Haid, who is the third-year pre-pharm student, and Rahaf Ahmad, who is a fifth-year pharmacy student at Al Ain University. They will tell us to know more about the central tendency of data variables. The panelists are Dr. Osama Tabara, IVPN President, and Dr. Ahmad Al-Rawini, Clinical Lecturer at Gulf Medical University. So, Rahaf and Shaima, the floor is yours.
Hello, everyone. Good evening. First of all, I would love to thank IVPN Student Network for their tremendous efforts and everyone behind the scenes for all the efforts that you put in and that you made this possible. I'm Rahaf Ahmed, a fifth-year pharmacy student, and I'm a graduating pharmacy student. So let me first start by sharing my screen. Just a minute. Great. So we're obviously going to be talking about central tendency. But before we start, I would like to have a little bit of a heart-to-heart conversation with you as pharmacists and as pharmacy students. Now, if anyone was involved in any research, published or not published, I want you to give yourself a pat on the back because it's a lot of work. And not only that, what goes into it is statistics. And actually, as pharmacists, we are aiming to discover new advancements in medicine. And I believe that as long as you got your as long as you're still a graduating student or a first-year student, when you have the bachelor degree in pharmacy or doctor of pharmacy, you studied the history of pharmacy. And now that we have equipped with this information, it's our responsibility to build on it and build our pharmacy community. And there's no better way to start with statistics like central tendency. So our objectives is discover the significance of central tendency, and I'll go in deep research into that. I'll talk a lot about that. And then know the description of data variables, and finally analyze the types of data and how to deliver the optimum statistic results. Now, our aim for this presentation is to help equip you with the right tools to be able to exceed and excel in the research community. So let's start with the introduction. So what is central tendency? Well, to put it easily, central tendency is a tool that will help us. Central tendency is a way of describing variables, and it's going to help us to give us a single value that's going to represent either the median or the median mode or mean, to give us the middle value and the most important value that will summarize for us data. So what is the significance of central tendency? Well, central tendency offers us two things. First of all, simplification and prediction. Simplification is it's going to help translate this complicated data to give us a single value. Like, look at this little figure right here. As you can see at the beginning, the data is very complicated, and what central tendency does is that it handpicks or it simplifies the data to only filter for us the most important things and the most important values, so we can later use it as in our description or our results. And prediction. So it doesn't only give us a single value, but it also helps us predict other scores and estimate future needs. Like, look at this example. An average American family has 2.3 children, and America is expected to grow with 1,000 families. So in 1,000 families in 5 years. So how many new classrooms need to be built? Well, knowing that an average family has 2.3 children, and we're expected to grow by 1,000 families, you get the idea that central tendency is much more than just research. Central tendency is important for governments, for medical manufacturing companies, for businesses, and much more. So let's start with describing the variables and the three approaches. So there are three describing variables: frequency of distribution, measure of variability, and measure of central tendency. I'm going to go in depth about the measure of central tendency, but I will touch slightly on the measures of variability and frequency of distribution, so I can give you a comprehensive overview. So let's start with the measures of variability. So we have the range, interquartile range, variance, and standard deviation. For the range, it's quite simple. It's just the difference between the highest and the lowest point. So the highest point here, which is 9, minus the lowest point, which is 3, and it's 6. And for the interquartile range, this is the difference between the 75th and 25th percentile. And speaking about interquartile range, I want to describe an evil word called outliers. I'm sure if you conducted any research, outliers are your enemy, because outliers are always, they don't represent the data, and they always skew our data. But with the interquartile range, we are able to tackle this problem and only focus on the most important 50% and avoid the extreme values. And then we have the variance, and the variance is basically the standard deviation squared. And next is the standard deviation. The standard deviation is the square root of variance. I'm going to go into details with everything. Okay, so first of all, with the interquartile range, we need to know 4 terms: Q1, Q2, Q3, and IQR. The Q1 is the lower, and the Q3 is the upper quartile, and the IQR is Q3 minus Q1. So let's look at this data. Now, this data set consists of, it's chronologically ordered. So let's start. What I like to do is find the median. So we can easily find the median by just removing one from here, one from here, and from here, one from each side until we reach our median or our middle value, which is 110. This is known also as the Q2. So any measure below this is lower and any measure above this is upper. So let's find the Q1 over here. It's very simple. We just need to cancel out this one, and now we're left with the Q1. As well as the Q3, we'll just cancel this, and we're left with the Q3. So now you easily guessed it that we're going to subtract 140 minus 15, which is going to give us 35. Now, is this correct? Yes. The difference from 15 to 140 is 35. And the benefit of the interquartile range is that it offers for us only 50% of the data, and it's not affected by the outliers. And it can easily be described by something called the box and whisker plot. The box and whisker plot will visually represent for us the IQR and the median. And as you can see here, you just need to identify each value, and as well as you need to identify what is the upper and lower extreme. In this case, the lower extreme is 5 and the upper extreme is 32. So once we plot these on the graph, you'll be left to add the median, which is 17, and the Q3, which is 20, and Q10. Now, this graph can tell us a lot. It can tell us that the Q2 is closer to the lower extreme than to the higher extreme, and the Q2 in the same time is closer to Q3 than Q1. Now let's move to variance. Now, variance might seem a little bit hard at the beginning, but once you learn about it, it's really easy. So the variance is the standard deviation squared, but it's also taking the value of each value and subtracting it by the mean, squaring it, and dividing it by the number of observations. Now look at these two data sets. They are totally different, but each one, when you calculate the mean is going to be both 10 for the same, which seems really strange. But this is why we have the variance. The variance will put everything into perspective. Once we calculate the variance, we're going to find that taking a value of each one, subtracting it by the mean and squaring it, dividing it by the amount of variables we have is going to give us the actual true variance. So the variance for data set A is 2, while for data set B, it's 200. The higher the variance, the higher the dispersion. So that's why dataset B is much more dispersed than dataset A. But this doesn't give us any terms that we can frame and put into a research. So that's why standard deviation comes hand in hand and helps us. So standard deviation is basically the square root of the variance. So for dataset A, it's square root of 2, and for dataset B, it's square root of 200, which is 10 to the power of square root of 2. So as you can see, dataset B is 10 times bigger than dataset A. Can we confirm this? Yes, we can confirm this, because once we look at the data, as you can see here, each value is 1 away from each other, while dataset B, it's 10 values away from each other. And this is why the standard deviation is one of the best ways to describe the dispersion of the variables. So now let's go for frequency of distribution. Frequency of distribution has to be one of the easiest ones and my favorite one, but unfortunately, I'll not go into detail about it. But basically, frequency of distribution is how much a number is repeated or how frequent it is. So for example, let's take this example, average heights of females in College of Pharmacy. Now, this is our frequency. So as you can see, the highest frequency are the heights from 1.6 to 1.78, because the frequency is around 13 students, while the lowest one is around 1, and their height is from 1.92 to 2.06. And now let's move to my favorite part, which is central tendency. Central tendency consists of mean, median, and mode. And I think this was discussed greatly by Dr. Bushra. Thank you, Dr. Bushra, for giving us a little bit of an introduction. So let's start with describing them. And we'll start with, let's start with the mode. The mode is the score with the highest frequency. So for example, this is a unimodal distribution. You can easily tell that this is the mode because it's the highest one. But can you tell easily from a graph, from a data set? Well, let's see the number that's repeated the most frequently. So 1 is repeated twice, 2 is repeated twice, 3 is repeated 3 times. Therefore, 3 is our mode. So yes, is 3 our mode? Yes, it is our mode. But until now, I only showed you the unimodal distribution. Let me introduce to you the bimodal distribution. The bimodal distribution is we have 2 peaks or 2 modes. So for here, we have the first one, which is the 5 and the 9. These 2 are our modes. So 5 and 9 are our modes. But bimodal distribution is kind of weird. It's a weird phenomenon. So why does it happen? Well, it can happen for 2 reasons. It can happen either if it's a true bimodal, which means actually there are 2 peaks that exist. So for example, Hodgkin lymphoma is a type of cancer that affects the lymphocytes, which are white blood cells. Now, it peaks at ages 15 to 34 and above 50 years old. So this is a true bimodal because it does peak at these 2 ages. While in this case of overlapping distribution, it's 2 different scores plotted in the same graph. Now, this is usually a mistake, but what we can do is that we can solve this easily by splitting the data. And now we have a local maximum over here and a local maximum over here. And now moving on to when should you use the mode? Because what's important in research is not only about how you can understand them, but I don't know why this is not moving. Okay. But it's also about when you should use them. So for the mode, you can use it in nominal data. You can also use it in ordinal and scale data, and when one particular score dominates the distribution, and when the distribution is bimodal, the best is median. Why is it better to use median, not mode and mean? Because mean and mode are not equipped to accommodate the skewed data, while median can accommodate the skewed data. So that's why. And then the ordinal and scaled also. So for ordinal or scale data, it's better to use the mode as a start or an easy approach, and then later you can use something that's more comprehensive. So let's take this example. Urticaria or rash. Urticaria is hives or it's rash. So let's say we made the survey, and what is the best homeopathic remedy for urticaria? One of the most is oatmeal. It's the most used one. So the most used one and the most frequent one is the mode. And now for the median. The median is at the geographic center or at the 50th percentile. So if it's at the 50th percentile, this means any value that is below it is going to be 50% of the data, and anyone that's above is going to be 50% of the other data. So how can we calculate the median? We can calculate the median by 3 simple steps. First of all, put it in ascending order. So let's see this example. This is a data set, but it's not in order. So let's order it. Okay, now let's try to find the median. I love this because I get to scribble around. I feel like a teacher. So let's remove one from each side, and we end up with our median, which is 5. So is it really 5? And how can we make sure? Well, we can make sure by this simple formula, which is n plus 1 over 2. So let's count which position is 5. 1, 2, 3, 4, 5. It is in the 5th position. So how can we make sure that this is correct? Well, n is 9. N is the number of observations, and there are 9 numbers. So n plus 1, which is 10, over 2, which is 5, in the 5th position. So we are correct. But this is in an odd data set. But what if we have an even number of data sets? What should we do? If there's an even number of data sets, we can take on the next approach, which is either by making n over 2 and n plus 1 over 2. So this data set right here is not in order, so let's start with ordering it. And then let's scribble out 3 and scribble out 3. And our median is 2 numbers, 15 and 17. So we have 2 medians. But what do we need to do? What we need to do is add them, find the average. So we need to add them and divide by 2. When we added them and divide by 2, we're going to find that the median is 16, which is correct because it is in between 15 and 17. So, but this is only for a small set of data. I want to generalize it. How can I use it on a big set of data? Well, we can easily use the formula again, n over 2 and n plus 1 over 2. Now, when I was studying this, it arose to me, why n plus 1 over 2 again when we repeated it? Well, because if this is our data set, if this is our median, then this is n. So n plus 1, 1 after n is 17. So this is why this is for the first median and this is for the second median. And the median is the average of them. And when should we use the median? The median is really useful in skewed data. So we can use this instead of in the bimodal distribution. This is the perfect thing you can use because it will only give you one score. And it's also useful in ordinal data. But this phrase really made me curious. It will not always be one of the actual scores. Is this true? Well, yes, because look here, 16 is not an actual score and this is the median. So the median is great for skewed data, while the mean and the mode are not good for skewed data. So let's go to the final mean. The mean is known as the average or the big boss. So the mean is actually really simple and really easy. So if you have a good time and everything is easy, you're going to get a normally distributed curve, which is a bell-shaped curve. And when you have a bell-shaped curve, the mean is equal to the median and the mode. So if the mean is 10, then the median is 10 and the mode is 10. But how can we find it in a data set? It's very easy. We already did this multiple times. So let's just discuss it one last time. We add all of them over the number of variables. So we added each one over 8, which gave us 155 over 8. And the mean is 19.37.5. So when should we use the mean? We should use the mean in interval or ratio data, which are quantitative, and when it's normally distributed. Never use the mean when it's skewed or when it's qualitative. So what are some important properties of mean? It is the center of gravity and it has sensitivity to extremes. So that's why you shouldn't use it for skewed data. Okay, so let's summarize and let's increase the stress a little bit. I'm going to open the chat box and you have 5 seconds to answer each question. Whoever says it first, whoever answers first, I'm going to announce their answer. So, quantitative research, which measure of central tendency should we use? Okay. Which measure? Oh, no one answered. Okay, 5 seconds passed. Okay, qualitative should be the mode. Qualitative should be the mode. Okay, quantitative research, what should we use? Yalla, 5 seconds. 5, 4, 3, 2, 1. No. Okay. So for quantitative, we can use either the mean, median, and sometimes the mode. Okay, so look at this graph right here. This is a bell-shaped curve. What is the best thing we can use for it? If you guess the mean, then you're right. And what about this positively skewed data? What's the best thing to use? I think you guys memorized it by now. It's the median. So yes, this is for my part, and I'm going to hand the mic to my fellow presenter, Shaima. Thank you so much.
Thank you so much, Teja, for your entertaining and informative speech. And now this is Shaima Abu Haid, a third-year student from the College of Pharmacy at Al-Ain University. I will be discussing with you all the pros and cons of all the 3 measures of central tendency that were explained by Dr. Rahab. And finally, we'll be solving an example, including all the 3 applications of the measures. Okay, so starting off with the mean. One benefit of calculating the mean is that it can be used to draw conclusions about the data we have, given the examples of standard deviation and variance. Or in other words, we can say that it is the base of the inferential statistics. And as also previously explained by or mentioned by my colleague Rahaf, it can be useful when describing interval and ratio data. And it represents the center of normal distributed data. Now coming to the last advantage, which also contributes to one of the disadvantages of the mean, is that when we calculate the mean, we do not exclude any information. And we include all the values. So this means that when we want to, if one of the values is missing, we cannot actually calculate the mean. However, and as the mean, this will make our progress, it will delay our progress in our research, as we have mentioned, because the mean is the base of inferential statistics. Okay, another disadvantage of the mean is that it can be affected by, my apologies, it can be affected by, what did it, the slide change? Okay, no, okay, I'm sorry about that. Okay. So another disadvantage of the mean is that it can be affected by the presence of outliers or extreme values, as it is an average calculation. In addition to that, considering that the mean is an average calculation, this means that it may not actually exist in the set of data we have. Let's take the examples of having our data as numbers. Let's say the number of apples that a group of 4 friends have. Let's say 1, 2, 4, and 5. So the mean of this set of data will be 3, which does not actually exist in this set of data. And finally, there will be an increased chance of having errors when calculating the mean if the values are repeated in the set. Okay, so next up is the median. It is not affected by extreme values, giving it an advantage over the mean in this criteria, since the mean gets affected by extreme values. So unlike the mean, the median can be extremely handy when dealing with qualitative data. For example, ordinal values or ordinal variables. For instance, measuring the economic status when using hierarchy, such as wealthy, middle income, or poor. However, there is no clearly defined interval between these categories. So it is very hard to calculate a mean using this data. So we go for the median. The median is easier to compute, and it also minimizes the total deviation, since, as we have mentioned, it is not influenced by skewed distributions, as in if the frequencies were concentrated at a certain range of values. Now, this also means that the mean does not take the actual values into account, which could be a disadvantage. Let me show you an example. Can we move to the next slide, please? Let's take a look at box B, where we have 2 sets of values. They have the same ranges, same median. They have the same number of values. So if we didn't actually look into these values of the sets, we would just assume that the 2 sets are identical, which is not true, since every set has its own mean if we calculate it. Okay, so let's go back and take a look at box A. So what do you see in there? Now, the first set of data has an odd number of values. We easily figured out what the median is, which is 5 in this case. However, the second set of values has an even number, where we need an extra step to calculate it, which is finding the average of the 2 central numbers. And we ended up getting 4.5, which is a number that, again, does not exist in this set of values. So this concludes 2 cons of a median in the case of even distributions. Number 1, the median does not exist in the set of data. Number 2, the median is ambiguous. Finally, looking at box C, the number of data is very large. How long will it take you to find the median? Well, I didn't have the time to find it while preparing for the presentation, so it actually does take quite an amount of time. So realistically talking, the data used for research will contain at least 500 samples, which means over 500 values to be calculated. So this will give us the disadvantage of consuming so much time. Now let's move on to the mode and talk about the advantages and disadvantages of the mode. Now the mode, it shares some advantages with the median, such as being useful with the qualitative data and being easier to compute. However, it solves some problems, such as coming from the data set and not being affected by the extreme values, unlike the median and mean. It also shares some disadvantages with the median, such as ignoring most of the values. Small samples may not have a mode. If you recall the example of the 4 friends with the different number of apples, we said 1, 2, 4, and 5. So in this set of data, we do not have a median. It's a very small set, and we do not have a mode. So, okay. So, and also, unlike the mean, it cannot be used for further mathematical treatment, since we said the mean can be used for calculating standard deviation, for calculating the variance. The mode cannot be further processed. And lastly, it is very highly affected by the fluctuation of data. Okay, now let's move on to our example, and let's try to solve this together. I really want you guys to write some answers or guesses in the comment box. Okay, so here, as you can see, there is this table showing the monthly salaries of employees for the 5 months and for the 5 months, January, February, March, April, May. Okay, and we have the values of 105, 95, if I see correctly, 105, another 105, and $100 per month. Okay. So let's start off first by trying to calculate the mean. Can we do this really quickly and check? And let's check the comment section, please. It's not visible for me. Okay. Any answers? All right, so let's not take more time. Okay, so we calculate the mean by adding all the numbers in the set of values and dividing by the number of values, which is 105 plus 95 plus another 105, 105, and 100 divided by 5, which will give us $102, and that is the mean monthly salary of an employee. Moving on, let's try to find out the mode, which is clearly here now 105, since it's the most occurring value in this set of values. And finally, calculating the median or finding out what is the median. So it is the central value, which is in this case, again, $105. So this is how we come to the end of our presentation. I'd like to thank all the team members. And first, I'd like to thank Professor Asim Al-Noor and Dr. Zainab Abdel Nasser, which is the leader of our team. And thank all the other members who have also contributed and assisted and helped out in preparing this presentation. So thank you so much. And we are ready for any questions.
I would love to thank you, and I would love everyone for participating and for listening to us. And thank you to all our team members, because this wouldn't have been possible without you.
Thank you, Rahaf and Shaima, for the wonderful presentations. You made a very complex topic sound very interesting and easy to follow. And now I would like to hand over to Dr. Osama and Dr. Ahmed Al-Rawaini for the Q&A.
Yeah, mashallah, Rahaf and Shaima, that were an amazing presentations. This reflects really a high level of passion and a higher level of mentorship by Dr. Asim. I see the fingerprints of Dr. Asim everywhere in your presentations. You know, in fact, in presence of Dr. Gareth, Dr. Hijazi, Dr. Awaini, Dr. Asim, I don't feel comfortable at all asking technical questions. You know, it's not my area of interest, and I truly feel shy of asking any technical question. However, I have a leadership question in research. So allow me to ask this question, and I expect a short answer from Rahaf and Shaima. So the question is, what is the purpose or motivation behind conducting a research, especially by students?
I honestly, thank you, Doctor, so much for the question, and thank you for this opportunity, first of all. And Doctor, especially for students, research is very essential, because as students, now that we gained the knowledge and now that we studied the history of pharmacy, it's our responsibility to start adding to our community and to pharmacy. Because we're gathering information not only from our universities, but as students, websites and amazing activities like such as IVPN helps us to also learn from many ways and many angles, not only from not like back in the day when we used to just learn from the library and from the university, but now we have many ways to advance ourselves and many ways to learn. So, and many new softwares like AI. So now we can really give out the best data to help not only the old diseases, find new cures for the old diseases, but we're also always faced with new pandemics and new diseases. So that's why I feel that students should really put their efforts, even in university, to try and contributing to research, because it will build them as a person and it will build their career. And thank you so much, Dr. Osama, for this question. Thank you so much, Dr.
Thank you. Shaima?
Okay, so I have this on my mind, like, you know, when we were kids and we're still actually very young, we always had those questions that are very different from what an adult would actually think about. So these questions, as we grow up, we can actually, if there were no answers to those questions present, we can actually look further into them and make an update into the research fields.
Amazing. Thank you, Shaima. Dr. Ahmed Laweni, I will leave the technical questions to you. Dr. Ahmed.
Thank you, Dr. Osama. Rahaf, Shaima, you really impressed all of us, I think. I was enjoying every single word you said in your presentation. Very, very well done. High level of confidence. Slides are appealing, no too much crowded, interactive, and you simplified, as the moderator Maria said, you really simplified difficult topic, but in simple word and with explanation and writing on the screen. As my mentor Dr. Osama said, we really sense the passion in your presentation, both Shaima and Rahaf. So very well done.
Thank you.
I have two questions for you. First, for the standard deviation, what type of data we can use, discrete or continuous?
Yes, for the standard deviation, go back to the slide. So for standard deviation, in my opinion, we can use yes. For standard deviation, we can use continuous types of data, because continuous is decimals. It's not, because the continuous can be more comprehensive instead of the other types.
Okay. Shaima, you have anything to add?
I'm sorry, can you come again with the question?
Yeah, my question was the standard deviation, we use it for which type of data, continuous or discrete or both?
Okay, I think it can be used for both, since we can calculate the mean for both discrete and continuous data, which means that we can actually calculate the standard deviation for both discrete and continuous.
Usually, the mean is more for the continuous, same as for the standard deviation. So most of the time, you see it continuous, not with the discrete actually, because with the discrete we use the frequency, the ratio, etc. Whereas or percentage. Whereas when we talk about standard deviation, it's with the continuous actually, and specifically. Normally distributed or nearly normally distributed data. Okay, this is for the standard deviation, just to keep that in mind, because at the end of the day, why are we, this is a great webinar competition in terms of preparing you to read clinical articles later, right? When you are in the clinical field, when you want to digest a clinical trial, okay, the authors in this trial, they use standard deviation. Okay, is it appropriate? What type of data they used for, or they were testing in the primary outcome, etc. So standard deviation, just keep it in your mind. We use it for the continuous and mainly the normal distributed. Okay. My second question is, have you ever, came across the standard error of the mean, SEM? Because, maybe it's not 100% related to the variability and spread of data. It's more related to the uncertainty of data. However, because it's based on the standard deviation, that's why I wanted to check if you know it or we need to further explain it.
I can put in a little bit of input about
Yes.
that. The type 1 error or type A error and type B error, which is the false positive or false negative. And I honestly came across this in when I studied more about the COVID testing and false positive, false negative. So that's my addition to it. But
okay.
I would like
yes, Saima.
You have, I'm sorry, you have asked about the standard error, right?
A standard error of the mean.
Yes,
SEM.
which is the standard deviation divided by the number of values in the set.
Excellent. Standard deviation divided by the square root of the n. Yes, excellent. Yeah, exactly. So beside of what Rahaf said, which definitely when we talk about the errors, alpha, beta, and the power, when we talk about SEM, guys, standard error of the mean, this means that it is like the standard deviation of all the means. So basically we use it to estimate later on the confidence interval. I'm sure you heard about the confidence interval, right?
Yes, definitely.
95%, 90%, 99%, yeah. So we use it for this type of very important parameter to determine the significance and uncertainty of any data and outcome we get in any study. So I just wanted to, highlight this. But again, I wanted to thank you. Again, excellent job. Thanks to your, trainers, I would say, Dr. Zainab, Dr. Asim. And finally, I would like to thank all the organizing committee, Ahmad, Maria, Fatima, Kirtana, not to forget anyone, everyone here did a great job. So thank you for the invitation.
Thank you so much.
Thank you so much.
Okay, so now we'll be moving on to the last part of the webinar today, which will be with Tia Dabour and Ahmed Fadah, who are fifth-year PharmD students at Jordan University of Science and Technology. They will get us into knowing more about the integration of artificial intelligence in drug discovery process. The panelists are Dr. Gareth Dyke and Dr. Ahmed Abdudaim, lead of IVPN operations.
Hello everyone, my name is Tia Dabour and I'll be presenting with my teammate Ahmed Fadah our topic for today, which is artificial intelligence and its integration in the drug discovery process. First, I would like to state our objectives for today. Our first objective is defining artificial intelligence. Our second is a brief explanation of the drug discovery process. Our third is pharmaceutical applications of artificial intelligence. And our fourth, potential applications of artificial intelligence. One might ask himself, what is artificial intelligence? Although it's a very complex topic, it can be defined as a general term that implies the use of a computer to model intelligent behavior with minimal human intervention. We often ask ourselves, where can we find AI? In reality, AI is found in our everyday lives. Let's take, for example, Google Maps. AI plays an important role in making Google Maps such a reliable tool when it comes to navigation. Using data collected from mobile phone, satellites, sensors, they were able to create and train an AI program that can identify heartbreaking events and guide us to our destination and optimize our routes. It can also It can also suggest an alternative route, saving us time and directing us away from the hassle of traffic jams. Another example is accurate translation. We all know how accurately translating between languages has always been a struggle. Given the complexity of languages, DeepL has made this process much easier. Using newer generation of neural networks, developers at DeepL were able to create a translator that outperformed the competition. DeepL can capture the slightest varieties in text and translate them with great accuracy. Autonomous driving is also another example of an AI program. We can see manufacturers like Tesla already releasing versions of this. However, these cars can still require the driver to be fully attentive to gain control in case of a malfunction, which kind of contradicts the definition of an AI, which aims to have minimal human intervention as possible. However, scientists are using AI algorithms to assess and improve the safety of these cars. Predictive texting, although it seems sometimes annoying, it can be extremely helpful. But whatever your view is on predictive text it's still an application of an AI. It uses data from your typing patterns and learns from them, thus providing you with a more accurate prediction of what you're going to type next, thus saving us time. Let's now talk about powerful and amusing AI programs. NVIDIA Canvas uses artificial intelligence to turn lines and brushstrokes into landscape images. You simply choose the scenery you want to add and draw away. Take a look at this amazing video. Here, the person is just drawing and it's making a beautiful scenery out of the drawing. Another example of an amusing AI program, which is designed by OpenAI, is DALL-E 2, which is a web-based AI system that can create realistic images and arts from just describing it in normal language. It doesn't need any coding system or any specialized language. You simply describe the scenery you want and rest feels like magic. Again, take a look at this video. Here, the person is just describing what he wants to be drawn in normal language, and it's just drawing away. ChatGPT was created by a team of researchers at OpenAI using machine learning techniques. ChatGPT is a computer-based AI assistant that can provide information and answer questions. Its primary function is to assist users and provide information. Please keep in mind this slide because I'm going to come back to it at the end of this presentation. Now I'm going to talk about the drug discovery and development process, which is a very complex process, as all you know. There are 4 critical steps in the drug development process, with many existing stages in between each one. The first stage is early drug discovery. Early drug discovery involves the use of available assays to screen for appropriate target molecules and their subsequent hits, identify their therapeutic importance, and optimize them to improve their efficacy and minimize side effects. Research at this point is performed in the laboratory using in silico platforms, biochemical assays, cell cultures, and various animal models. The next stage is the preclinical phase. The preclinical phase is of great importance as it provides sufficient evidence regarding the safety of the drug before testing on humans can begin. And out of the 5,000 to 10,000 compounds enrolled, only 250 compounds reach the preclinical phase. Compounds chosen are purified, optimized, and extensively tested in laboratory, animal, or alternative models. Our third stage is the clinical phase. The clinical phase is composed of 4 major phases: phase 1, 2, 3, and 4. The remaining compounds are tested in a very small group of healthy subjects in phase 1. After that, phase 2 and 3 aim to examine effectiveness, tolerability, and identify the appropriate and right dose. Phase 4, the drug is tested on a larger study sample to confirm its effectiveness and safety before applying for regulatory approval. This takes us to the last step of the drug discovery process, which is regulatory approval. The data is analyzed, collected, and submitted to regulatory authorities for review and subsequent approval. Let's now talk about sub-processes of early drug discovery. As I said earlier, there are 4 main critical processes, but in between each one, there are sub-processes. Now, sub-processes of early drug discovery are of great importance. The first is target identification and validation. A good and thorough understanding of the pathogenesis of the disease is essential to identify a suitable biological target, which is said to be druggable. This moves us to the next step, which is high throughput screening and high content screening. Screening many molecules that can interact with the appropriate target identified is done. So after choosing a target, we choose a compound that interacts with that target, which takes us to the next step. The next step is hit identification. Hit is a molecule that interacts with the target and produces the desired therapeutic response. After that, we get the assay development and screening, which then is followed by hit to lead. After identifying a hit molecule, we optimize this hit molecule to get us to a lead compound. Lead compound, the screening process aims to reduce the number of these compounds into less and more qualified leads using in vitro and computer-based approaches, which leads us to lead generation and optimization. And last but not least, is in vivo and in vitro assays, testing the remaining compounds on conditions similar to living cells can commence. As you can tell, optimizing and releasing a drug into the market takes more than 10 years. Not only it's a time-consuming process, but a highly expensive one as well, costing more than $2.6 billion. This is why it's a perfect target for AI implementation, so we can cut this time and cost by a lot. Thank you. And now Ahmed Fadda will be speaking.
Thank you so much, Thea. With that being said, I'll be talking about the pharmaceutical applications of AI. And we'll start by talking about protein folding, which is a problem, an issue that we face with the, one second, sorry for technical issues. It is a problem we face when designing a new drug, because most of the time we are unable to identify how our target molecule looks like. Protein folding simply is the folding of a linear polypeptide into characteristic functional 3-dimensional structures. And as I said, it is very important before when developing a new drug that we know how the structure of the target looks like. However, because of the complexity involved in the protein folding, it is almost impossible that we can identify how the 3D structure of a protein will look like by simply looking at the primary amino acid sequence. That's where AI play an important role. And here we have two pioneering companies in this field. One is called AlphaFold, and one is called Swiss Model, both of which have different approaches to solving this issue. AlphaFold, first of all, is an AI developed by DeepMind that can computationally predict protein structures. And as a fun fact, AlphaFold was the first mind-blowing AI that I came across, and it was what got me into researching this field further. How do they assess the accuracy of an AI and protein folding? There is something called a Caspi assessment that uses a recently crystallized structure to compare the predicted structure with this compound. AlphaFold were able to achieve an accuracy of 0.96 angstrom compared to the second best method, which only produced a 2.8 angstrom. This is a counterintuitive scale. The smaller the number, the better accuracy it has. They were able to achieve such accuracy by incorporating novel neural network architectures and training procedures that used physical and geometric constraints of protein structures. Swiss model, on the other hand, is a fully automated web service dedicated to protein structure homology modeling. You may ask me, what is homology modeling? Homology modeling is simply, we have an unknown structure of a protein. We will compare that protein to a closely related protein, and then a computer can build us a 3D structure of our unknown protein. The Swiss model workflow is very intuitive and relatively easy to use. The workflow consists of data inputting. Then you search for a template to compare your protein to. You select the appropriate protein, and the Swiss model completes the model building and the 3D structure of your protein. Now that we have the issue of the structure of the target resolved, most of the times we have compounds that we don't know where they're active or where their activity lies. So we use a technique called target fishing, which is a process of identifying protein target of a bioactive molecule. So let's put a scenario here. Suppose you're working with plants and you were able to extract some phytochemicals. You want to know where these phytochemicals will be working. It would be, if you were to decide to determine this experimentally, it would require a significant investment of time and resources. As we all know, we have multiple proteins. We don't know, for example, this product, will it work on kinases, will it work on proteases, or which family of proteins will it work on? We can't simply just predict or assume where it will work. That's where AI works. An AI program called Starfish. It helps in the identification of natural products. It uses unique data set made from easily accessible databases like Zinc and UniDP to create a large learning set to help make the model as accurate as possible. Because in machine learning, the larger the learning set is, the more accurate the results are. And after completion, and validation, they found that between 85 to 95% of the compounds had a true target identified in the predictions of the AI. So about if they tested 100 compounds, between 85 to 95, they had a valid target identified. After that, we'll be talking about something called retrosynthesis, or as I like to call it, reverse engineering chemicals. We face some compounds that are complex in nature and are very difficult to synthesize. There's no direct route of synthesis. So we use a technique called retrosynthesis to decide the starting material of this, what could be the starting material that will lead us to this compound. And if we want to talk about boring definitions, I read this definition here. It designs a sequence of reactions to recursively decompose a target compound into simpler building blocks until commercially available starting molecules are reached. I love to use Taxol as an example because when Taxol was first made, they were facing a lot of issues trying to replicate it because, as you might know, Taxol comes from trees, and harvesting and extracting Taxol the yield is very little. So we need to find a way to synthesize this compound. Scientists all over the world try to race to find the best route to synthesize it. And using old methods, it required extensive expertise in the field of medicinal chemistry and synthesis. And more often than not, it produced suboptimal routes. However, with the recent rise in artificial intelligence, we can see artificial intelligence systems as good candidates in trying to predict starting materials of complex compounds. AI programs can fragment a compound into synthons. These synthons can then be rearranged and matched to a chemical that is available, commercially available, that we can use to build the intended compound from. And finally, for our last section, I'll be discussing some potential applications of AI. Where else you might think we can use AI? I personally believe that AI models can help us automate tasks that are mundane or redundant or time-consuming or take a lot of effort. It will help us save a lot of time. It will help us approach our experiments and our studies with more confidence, and it will decrease the probability of iteration later on in the stages of the studies. An example of this can be the NMR structure elucidation. It can be one potential use of AI. We can design a neural network that uses NMR data that's available from spectrograms, and then it will start to predict. When we analyze a new compound, it will start to predict its overall structure instead of resolving that structure manually. Another application could be in the HPLC method development. In the HPLC, finding an ideal separation condition is very tedious and requires a lot of trial and error to find the ideal method. However, using AI, we can minimize the number of variables that we need to think of, and we might even also be able to predict the ideal conditions of a certain mixture to separate it. And finally, the slide that Tia told you about to remember, I would like to state a fact that this slide was written by an AI. And the same AI that we were talking about, the ChatGPT, we simply asked it to describe itself, and we used it with no human intervention. And finally, I'd like to end our presentation with a quote that I like. AI is not a toy. It is a tool like a hammer, and it can be used to build or destroy. So depending on how we use it, it can be either something that would make life greater, or it would get us into an existential crisis.
It will take over.
Yes. Thank you. Thank you so much, everyone. And I'll be waiting to hear your questions.
Thank you so much, Tia and Ahmed. It's pretty interesting to hear your presentations and to see how AI is transforming every aspect in our lives, including pharmacy and research. So now I'd like to leave the floor to Dr. Ahmed and Dr. Gary.
So good evening, assalamu alaikum everybody. Thanks for inviting. It's definitely a pleasure not only to be with these to be with and learn from these promising talents who are actually, I believe, to be not believe. I think I am sure that they are the leaders of the future. So future is in safe hands, and as well being with leaders like Dr. Osama Tabara, dear Maria Halima, Ahmed Rawani, everybody, and last but not least, my dear beloved friend and mentor, Dr. Gareth Dyke. It's always be here to lead the floor with you. So I'm leaving the floor for you for a question before I go. So you are the expert here, sir, before I go. So please go.
Oh, that's very nice to be here. And thank you so much. That's wonderful. That was a great presentation. And thank you very much for it. Like, I learned a lot. And we actually, we are in an existential crisis as editors and companies that provide translation services, because of things like our friends at ChatGPT and others. So my first question, I mean, you covered a lot of ground in this presentation. So I'd like to ask, like, in your opinion, where is the most fruitful application for AI in this field in the future? Like, if you could pick one area that you would focus on, like, where would you focus?
Regarding pharmacy?
Regarding pharmacy, sure, yeah.
I think the drug discovery and the development process is of great interest of applying AI. It can cut us time, it can cut us effort, it can cut us a lot of money. I think in particular the preclinical phases, as it deals a lot with models in the laboratory, so you can implement AI programs in the laboratory and improve them so you can get better structures and a faster process, in my opinion.
Do you have any examples of the application of AI to that kind of discovery?
I think I can't remember exactly what the name of the drug was, but I think there were some few kinases that were synthesized in silico and tested in silico, and then after that it was transferred to real life synthesis, and it passed clinical testings, and it became eventually a drug that's used today. I can't remember exactly its name.
A huge saving then. That's great.
Oh yes, it definitely is. It does not only does it save us time and help us cut on the mundane tasks, but it also helps us approach problems more confidently. Like we can be more confident that our approach is correct, or we're heading in the right direction instead of going in blindly.
It minimizes human errors.
Yeah, risking investing money and time and then wasting that for when nothing works.
Well, thank you.
Yeah,
Great.
I do think there is a lot of potential applications for artificial intelligence.
And it was a great presentation. Thank you very much.
Thank you so much.
Thank you so much.
Thanks, Dr. Gareth Dyke. Dr. Gareth Dyke is definitely a researcher, and his basic, field of expertise or research is mainly archaeology, if I'm not wrong. So I'm happy because you touched on the two things that came to my mind, actually, despite being a pharmacist. So it's the same issue. Firstly, I would like, to say thank you very much. Very concise. I'm not complimenting here. Very concise, to the point. Very good flow of ideas. A very good flow of presentation. Really amazing, especially I like the presentation more than even the content itself. How you managed to match the theme of the presentation as an artificial intelligence, what you talked about, and what design did you use. Just again, it's a learning opportunity for everybody, including me. So I just wanted to highlight what I really liked. Going into the topic, so starting with whoever is being able to answer. But for Tia, as you mentioned, it can save the cost, and definitely instead of going into hectic, stages of drug design or drug clinical trials, it can save the cost. But on the other side, and again, maybe there is no clear answer or clear-cut answer to that question, but what do you think about the accuracy? So we have used to these clinical trials for a long time. We are accustomed to it. We are, more, confident in its results to a certain extent. The artificial intelligence can save us cost, but would it be at the expense of getting an accurate results or maybe safe results? What do you think? Again, it's based on your reading. You're the expert here.
I think depending on where you apply it and how you apply it. If you apply it I think that clinical trials, which you test the drug on humans, it's kind of hard to apply AI there. As humans can offer the best like you cannot mimic the human body as accurate as as it is. So I think that there it might be a little bit inaccurate, but I was trying to refer to laboratory and in silico designs where you can apply AI there to make it a little bit easier to come up with results and improve accuracy and minimize human error.
Yeah, thank you very much. It makes sense. So to start at least at the preclinical level, then we can check these models and see to what extent they work. So I believe it makes sense. Thanks for being with us. Thanks for the great presentation.
No problem. And thank you for all your questions. And thanks for this opportunity.
It's definitely always our pleasure. So moving to our dear Ahmed, again, great presentation. I always stuck with this. I'm an old generation guy. I always stuck with these technology things. So I feel in a safe hands. Especially you touched on something, dear Ahmed, about protein synthesis, which is I think it's the fashion of this era, going into biologics. I think you've heard about them. You touched it even on one of them. So to what extent do you think that artificial intelligence can solve this puzzle of biologics or can help with it, especially that you touched on kinase inhibitors and so on?
So the area I was talking about was in the protein protein folding issue. Because as you know, if I understood your question, you're still talking about
I
protein
cannot hear.
folding,
I'm not
right?
sure.
You were asking about protein folding.
No, generally speaking, biologics.
Oh, okay. Generally speaking,
Yeah, go on.
Okay, so thank you for that question. Having the ability to visualize and to visualize these things makes it more efficient to solve a lot of these issues. For example, if we were going to talk about docking studies, let's say, yes, how a docking study works, we need to have a 3D structure of a protein, and we have a compound that we assume will work on this protein, and it will measure interactions and affinities, etc. Now, how can AI be used here? It can be used, for example, to give us a scaffolding of what it thinks might be a good contestant to bind to this protein, a good candidate to bind to this protein, to give us the intended therapeutic effect. For example, it can work the other way around. We have a compound that can give us where do we think it will bind, and what effect will it have? Will it be an antagonist? Will it be an agonist? Will it be a positive modulator? Will it be a negative modulator? So I really do think that with the progression in computational technologies and computational powers, and add to that the availability of cheaper, more renewable energy, I really do think that AI users will be skyrocketing soon. And I do think as pharmacists, we should be progressive and thinking towards in that direction to help improve and develop further and further to keep up the pace with it all.
And as I told you, I'm sure that the future is safe with this in the hands of such, great talents. I think you answered the question, because the problem with biologics is usually that just to give the people idea what are biologics, like insulin, if you want to mimic insulin, it's not easy. It's a protein. It's not easy process. So the only way is to visualize this, to see how it docks into the receptor, how it interacts with the human body. If you are if a company produces something that's similar to insulin, so would it give the same effect? To the moment in the clinical practice, it costs a lot of money, a lot of effort to investigate this. So I believe, dear Ahmed, from what you explained to us, I believe it may be to a great extent provide a solution to this biologics issue. So thanks to you and Ahmed and everybody.
I would like to show the reference slide. Please, Ahmed, can you please?
Sure.
Just to make sure
These
that they're there.
Our references that we use to help create this presentation.
I'm really interested in them. So for everybody who's asking, I believe that our dear colleagues from IVPN students will make sure that these slides will be at your hand, so you can use at your convenience. So thank you again, everybody. Thanks for inviting me to be with these great minds to learn from them, and referring the mic back to my dear friend and colleague, Dr. Maria Halima. Dr. Maria, floor is yours.
Can I intervene? Little?
Yeah, sure.
Yes, Ahmed, the NMR and HPLC is your idea, or something from just you got it?
No, actually, the NMR was an idea of daydreaming. I was thinking about it, then it came to my head, and the HPLC was inspired by Dr. Arif Zaid. I'm not sure if he's attending here with us.
Oh, yeah. So these are ideas that, because Ahmed is one of my students, and he always thinks about ideas, so I know this is his idea. So I just wanted to highlight that, because it's not something he found. It's a novelty from his mind.
Thank you so much, Dr.
Thank you.
Thank you so much, Dr. Bushra, Dr. Ahmed, and Dr. Gareth. At last, research cannot address the entire scientific challenge, and statistics is the basic foundation of medical science. That's why it is important in our lives and cannot be ignored, as it is the basis for research. Concluding these effective presentations, Nabil and Kavla provided us with a closer look at observational and experimental studies. Shaima and Rahaf described the significance of central tendency in scientific research. Ruth and Fatma taught us about the types of data, and Ahmed and Tia came up with the integration and implementation of AI for better treatments. So in the end, I'm thankful to all of you for attending our Youth AR. All presentations were very informative, and we like to appreciate our presenters for their performance. Special thanks to all the panelists on the part of IVPN Webinar Committee for delivering great knowledge about biostatistics and research. Handing over to you, Maria.
Thank you so much, Larib. And now moving on towards a short Q&A session. For that, I would like to call Dr. Ahmed Rida and Fatima Sheikh.
I hope there's